In this video, we are going to discuss a topic which is an extension of intersection of projection of solids. We see over here that a triangular prism and square prism are intersecting each other. As a result, there is some common portion of intersection in both the solids. This is what we are going to discuss in this video, that is, what is intersection of solids and what are the methods to produce these intersections. Here there is a cone intersecting a cylinder. If we observe very carefully, the points where the intersection happens is a typical curve. This curve is known as curve of intersection. This looks more like an abstract idea than something useful for engineering purpose. So, why do we need to study this? When two surfaces are joined together, some bonding agent needs to be applied at the part of intersection for stability. And for the stability to be maximum, the curve of intersection should be long enough. In simpler words, we need to maximize the length of curve of intersection for a better design. This terminology is applied in numerous fields. Suffice to say that wherever a weld joint or glue is applied, this concept is applicable. If two solids with hard edges intersect, then we get a line instead of a curve. This is called the intersection line. If two solids with at least one of them having a curved surface intersects, then an intersection curve is formed. So, that was an introduction to intersection of solids and its purpose. Now we need to discuss some important cases about them. These cases depend on the type of intersecting solids, the manner in which they intersect. Firstly, let us discuss intersection of two solids based on the type of intersection. The two intersecting solids are of the same type, for example, a prism intersecting with another prism. The two intersecting solids are of different types, for example, cone intersecting a cylinder. So, these are the type of intersections based on type of intersection. Now, let us see the manner in which they intersect. There are many possibilities in this regard. The solids intersecting can have their axis parallel, inclined or perpendicular to each other. The axis can be aligned, offset or coinciding. Putting all this together, the intersections are classified as Case 1, axes are perpendicular and intersecting with each other. Case 2, axes are perpendicular and offset with each other. Case 3, axes are inclined and intersecting with each other. Case 4, axes are inclined and offset with each other. Case 5, axes are parallel and coinciding with each other. Case 6, axes are parallel and offset with each other. These are the various possibilities and we shall explore them in the next video. In our previous video we got ourselves familiar with intersection of solids and various possible cases of intersections of solids. In this video we are going to know how to obtain the intersectional views and what the methods are. Basically there are two methods to obtain intersectional views of the solid, and they are line method of intersection, cutting plane method of intersection. Firstly, let us discuss the line method of intersection. As the name suggests, this method uses lines for obtaining intersection surface view. In this method a number of lines are projected on the lateral surface of one of the solids and on the surface where these both solids intersect. It means parallel lines are drawn on the lateral surface of one of the solids and on the intersection region to obtain the true shape of the solids after intersection. Basically, in this method of intersection, firstly, lines are drawn from lateral surface of one solid and onto the line of intersection, then points of intersection of these lines with the surface of other solids are located which lies on the required line of intersection. They are more easily located from the view in which the lateral surface of the second solid appears edgewise, that is, as a line. The curve drawn through these points will be the line of intersection where both the solids share a common surface. This is how the intersection line of the solid is obtained from this method. Main advantage of the line method is that this method can easily locate the intersectional view of solids whose lateral surface is made up of straight edges, like prisms. Now second method is cutting plane method. In this method assumptions are made that both the solids which have intersected each other are cut by a series of cutting planes. With the help of these cutting planes, the line of intersection is obtained. In this method, cutting planes can be taken as vertical, that is perpendicular to HP, horizontal, that is perpendicular to VP, inclined or oblique. A cutting plane is selected in such a way that it cuts the surface of one of the solids in straight lines. And it can cut the other solids either in a straight line or a curve. This method is very accurate and can be applied easily, as solids which intersect each other are divided into series of planes, and then separately intersection surfaces are obtained. We will understand how to apply these methods in further videos clearly. So these are the two methods to obtain intersectional surfaces we have discussed. There are some important points that everyone needs to know while drawing intersection of solids, and they are: intersections can be obtained by multi-view drawing like front, top, auxiliary and side views too. The line of intersection can be obtained using auxiliary views and cutting planes. When a solid intersects with another solid in such a way that it completely penetrates another solid, then there will exist two lines of intersections. As shown here. We can see here the cylinder completely penetrates the cone, thereby forming two lines of intersections on both sides of the lateral surfaces of the cone. So these are the points one must know while drawing intersections of solid. Now there are some common steps which are applied in both methods of intersection to obtain the intersectional surface of the solids. And by following these steps in a sequence, we can easily obtain intersection of the solids. So let us see what are these common steps of solution. Step 1. Firstly, assume that any one of the intersecting solids is standing on HP. Step 2. Let the other solid penetrate horizontally through the solid which we have assumed standing on HP. Step 3. Now, after drawing both the position of the intersection solids mentioned in Step 1 and Step 2, now draw all the views, that is, front, top and side views of that solid which we have assumed standing on HP. Step 4. Now draw all the views of the penetrating solid, beginning with the side view, then top and front view of the penetrating solid. Step 5. Now on the side view of both the solids, mark the points and give them lettering. Step 6. For marking points, follow this rule that the points which are on standard edges, standard generators and on the edge of the solid standing on HP, mark that points on their respective front view and top view. The remaining points should be first located on top view first, and then on front view. Step 7. Now draw the dark and dotted lines with the help of side views from its right side dot. Step 8. It's the last step to obtain the intersections of the solid. In this step, the obtained intersections from Step 8 are joined by straight lines or curved lines, depending on the solid's lateral surface. These are the basic common steps which are to be followed in both line method and cutting plane method of intersection. In this video, we have gone through methods of intersection and steps to obtain intersections of the solid. In our next video, we will be solving some problems of intersection of solids. In the previous video, we have seen different methods to obtain intersection of solids. In this video, we will focus our attention to a specific type of intersections. They are the intersection of prism versus prism and cylinder versus cylinder. We will study penetration of solids of the same type. Firstly, we will see the intersection of prism with a prism, and then a cylinder with a cylinder. So let us study these one by one. Intersection of prism and prism. In this case, prism intersects with another prism. This type of intersection is an intersection of the same type solid. As an example, here we can see a square prism intersect another square prism. As we know that prisms are composed of straight edges and have plane surfaces as their faces. So the intersection formed when two prisms intersect each other will be straight lines. Now let us discuss how lines of intersection can be obtained in the intersection of prism versus prism. The line of intersection between two plane surfaces of prism is obtained by locating the points at which the edges of one surface of prism intersects to the surface of another prism. These points are called vertices. After locating vertices, join these points with a straight line. The obtained surface will be the intersectional surface of the prisms. The line of intersection formed between the intersection of two prisms is therefore a closed figure composed of straight lines, such that they only meet at vertices. Let us understand this more clearly by solving a problem. A vertical square prism of base 30 mm side and height of axis 70 mm is completely penetrated by a horizontal square prism having base side 25 mm and axis 70 mm so that their axes intersect. The axis of the horizontal prism is parallel to VP, while the two faces of the prism are equally inclined to the VP. Draw the projection of solids, showing their line of intersection. In this question, one prism is penetrated by another prism, so to obtain a line of their intersections, we will follow common steps which we had seen in our previous video. This is the pictorial view of the question. Now let us see how to obtain the projection of this problem. Procedure to draw the projection of intersection of lines of these solids. First, write the given data on a drawing sheet. Base side of vertical solids equals 30 mm. Height of axis of vertical prism equals 70 mm. Base side of horizontal solid equals 25 mm. Height of axis of horizontal solid equals 70 mm. Now step 1. Firstly, draw the different projections of the vertical prism. Starting from top view, then front view and then side view. Draw the top view of the vertical prism, because true shape of the object is visible from top view only. Draw a reference line. Draw a square edge 30 mm. This is the top view of the vertical prism. Now draw its front view. Project the construction lines upwards from corners of the top view of the vertical prism. The front view of the vertical prism is a rectangle of height 70 mm, and its width can be projected from the top view. Draw the rectangle length 70 mm with the axis in the middle. Name the top face of the prism. Here our front view of vertical prism gets completed. Now it's time to draw a side view of the vertical prism. For that, extend the construction lines on right side from corners of the top view and stretch these lines. The side view of the vertical prism is also a rectangle of 70 mm height. Its width can be obtained from projection lines. Draw the rectangle with an axis in the middle. The face that is seen from side view will be 4, 3, 2, 1. So name the top face of the side. Here our side view of prism gets completed. So we are done with all three views of the vertical prism. Now it's time to project different views of the horizontal prism. Firstly, draw the side view of horizontal prism, then top view, and then final front view. The side view of the horizontal prism is a square of edge 25 mm. This square lies centrally on the side view of the vertically prism dot. Here our side view of both prisms gets completed, now moving towards the top view of the horizontal prism. Project the lines from the corners of the side view of the vertical prism, that is from B, A, D, C, towards the top view of vertical prism. These lines will definitely intersect at some points. Now the top view of the horizontal prism will be a rectangle of axis 70 mm, such that our square lies between this rectangle. So draw a rectangle with an axis 70 mm at the middle. Its width can be obtained from projection lines of its side view. Here our top view of horizontal prism gets completed. Now draw the front view of the prism. The front view of the prism will be a rectangle of length 70 mm. Now to obtain its width, project the construction lines on the left side from the corners of the side view of the horizontal prism. So draw the rectangle of length 70 mm with an axis in the middle and width of projection lines positioned centrally on the front view of vertical prism. Here our top, front and side view of both the prism gets completed. Now it's time to project the intersection points. To locate the intersection points, we can see that the top view of both the prisms intersects each other at points. Now shift that intersection points upwards on the front view using construction lines. These lines will intersect the front view at their respective edge. We will obtain intersection points at the front view of both the prisms. Give lettering to those points. These points are only vertices. Now join these points using a straight line, as the line of intersections of the prisms is a straight line. Here in front view we will obtain the intersection lines of both the prisms. The front, top and side view give a complete view of both the prisms after intersection. This is the required solution of the problem. This is how we can obtain intersection lines of the solids intersecting with each other. In this video we have seen the intersection of prism versus prism. We have obtained the straight line of intersection. In our next video we will come with the intersection of cylinder versus cylinder and will obtain a curved line of intersections.